This is Sarah Parker, and this is my explanation for Assignment 2 for CPSC5010. The first assignment was 2.1, which was to calculate the perimeter of a triangle. The first thing that we did is included the IO stream because we are going to be taking input from our users. And then we're also using namespace std so that we don't have to type that every time we want to do an in or an out. The first function that was created returns a Boolean value to verify the validity of a triangle. And a triangle is valid if the sum of two edges is greater than the remaining edge. So we tested all of this by doing edge 1 plus edge 2 is greater than edge 3, and edge 1 plus 3 is greater than 2, and edge 2 plus 3 is greater than edge 1. So we're checking the validity of our triangle first and returning whether it's a true or false value. We will be using that later on. If it's true, then we're going to move on to our next function, which is to compute the perimeter of a triangle, which takes those edges, 1, 2, and 3, adds them together, and returns them as a double. In our main program, we have declared our 4 double variables, edge 1, edge 2, edge 3, and the perimeter. We're asking our user to enter the 3 edges of a triangle, and then we're saving those from the terminal back in to edge 1, edge 2, edge 3. Here I'm using an if-else statement. So if, and then we're calling our function verify validity and passing in those 3 edges that our user provided. So if our triangle is valid, then we want the perimeter variable saved by calling the function compute perimeter with those 3 edges. So essentially, if our triangle is valid using this function, then compute the perimeter using our second function. And then print that statement to the terminal with the sum of our edges. If it is not a valid triangle, so if this is a false Boolean value, then we're going to print out this is not a valid triangle. I will go ahead and run the program so that you can see what happens. I've already compiled it, so we're just going to run it. And we're going to do a valid triangle first. We're going to do a 3, 4, 5 triangle. Hit enter, and this gives us the perimeter of 12. If we run it again, and we do 1, 2, 3, this is not a valid triangle, and our program does print out that statement. Moving on to our second program. This one is called, this is 2.2, so this is circle geometry. So essentially we are writing a program where our user is going to enter the XY coordinates to be the center of a circle and then the radius of that circle, and then repeat that doing a second circle. Our program will then calculate whether the 2 circles are overlapping, one circle's inside the other circle, or the circles do not overlap at all. So essentially, I was playing around with this a little bit. We can go ahead and delete this comment actually. I created a function that's called overlapping circles, and it is void, so it is not going to return anything, but it is going to calculate our circles using 6 inputs. So we have our XY value of 1, and then our radius of circle 1, and then our XY value of 2, and our radius of 2. So the way that this function works is our distance is calculated by using some math functions, which I should have stated. We included the math header at the top of our file so that we can do these math functions. So our distance is going to take the square root of the power of x2 minus x1 and 2 plus the power of y2 minus y1 to 2. If the distance is less than or equal to the absolute value of the radius of 1 minus the radius of 2, then it's going to print out a statement that circle 2 is inside circle 1. If that distance is less than or equal to the radius of 1 plus 2, then our circles overlap. Otherwise, it'll print out that our circles do not overlap at all. The reason I made this a function is because we were asked to do edge testing to make sure that our program worked appropriately. So rather than asking our users for input in for the X, Y, and the radius, I did this in the main program. So our main program is going to print out a statement, and we're expecting this circle 2 to be inside circle 1. So it's going to print that out, and then we're calling our function overlapping circles, and we made our xy 0, 0, our radius of 5, our xy of 1, 1, and our radius of 2. And we expect that this circle 2 is inside circle 1. Our next edge case is expecting circle 2 to overlap circle 1. So the xy of our first circle is 0, 0 with a radius of 5, and our xy is 4, 0 with a radius of 3 for our second circle. And then our last case is that we expect no overlap between the circles, so our xy is 0, 0 with a radius of 5. And then for our second circle, our xy is 11 and 0 with a radius of 5. And then we're returning 0 because we're in our main program and we're ending it. So if you run this program, which we will go ahead and save it again and recompile it since I took out those comments. So let's go ahead and compile it. And it compiled just fine, so let's go ahead and run it. And this is what we expected, circle 2 to be inside circle 1, and our output, circle 2 is inside circle 1. We expected circle 2 to overlap circle 1 for our second edge case, and it does overlap circle 1. And our last one, we expected no overlap, and it did not overlap according to our program. So our program is working appropriately. For our third program, we calculated leap years. So this is assignment 2.3, and I created a function just called leap years. And we started our count at 0, and we're using a for loop to loop through every year starting in 2001 up through 2100, which is kind of weird to say. But we added year plus plus. So we're starting here, and then we're looping through this statement every year. We're using conditional statements to verify whether the year is a leap year or not. And determine whether the year is a leap year, we need to see if it is divisible by 4. So we're using modulo 4, but it cannot be, let me rephrase that. So it's a leap year if it is divisible by 4, but not divisible by 100. And we're using the modulo to verify that. So it is divisible by 4, so that means a 0 remainder. And divisible by 100 does not equal 0. So that's saying it's not divisible by 100 because we have a remainder that does not equal 0. Or, that's what these two lines mean, our year is divisible by 400. So we used modulo to make sure that we had 0 remainder to equal 400. And then we're printing out the year if it is. So if we meet these conditions, then we print out the year with a space. We add to the next line, and then we go back up. If our count is modulo 10, so once we hit 10 years, it should start a new line, then we end the line and go back up and continue our process. So in our main program, we're running our function leap years and returning 0. So let's run this program. Leap years. And I think I've already compiled this, so it should work okay. Yes, okay. So we have printed out 10 years with a single space in between each one, starting with 2004 was the first leap year after 2001, and then up until 2096. And I did verify that online to make sure that those years were accurate. Our last program is 2.4, and this program, come come back here. This program asks us to prompt our user to enter a year in the first day of the year. So let's say if our year is 2013, what day does January 1st fall on? So in order to, and then it calculates the first day of each month from there. So to start off with, we created a function, and this function is going to print our first days, and we're passing in parameters year and start day, which will be passed in by our user later on. So we created an array of strings called days of the week, Sunday through Saturday. And then we also created an array of strings for our months, January through December. And then we created an array of integers to correspond with the number of days in each month. So 31 for January, 28 for February, 31 for March. We are going to account for leap years as well, which is this next if statement. So we're using the same condition that we used in our leap year program to test whether it's a leap year. If it's a leap year, then we're changing the days in the month at spot 1, so 0, 1, instead of 28, it becomes 29. Then our current day is our start day. So we're going to loop through each month, and then we're going to output the month here. So we're going to access our string array of months, starting with the month. So if it was 0, it would start with January, and if it was 12, it would end with December. Sorry, it would be 11. It has to be less than 12. And then it will print out the year, and then the day of the week, and the current day. So then our current day is going to equal our current day plus the days in the month. So that's accessing this array with the month, which is going to access whatever month we are currently on in our our for loop will be here. So days in the month, if we're on our second iteration, it would be 1, and that would be 28 as long as it's not a leap year. And then we're going to do that by modulo 7 so that we can update the start day for the next month. So this one was a little bit more confusing to get through, but I do believe the program works right. So in our main program, we have 2 variables that we're declaring. It's the year and the start day, which we're getting from our user. So our output is asking them to enter the year, and then we're saving that in year. Same thing, asking for the first day of the year. So we're doing this with our integers. So our user is not going to input Sunday. They're going to input 0 if they want Sunday, 1 if they want Monday, and so forth. We're going to validate that they didn't enter some crazy number like 23 by putting parameters that our start day has to be greater than 0 and our start day is less than 0 or greater than 6, then it's invalid. So if they put in 23, it would not meet this condition, and it would say that it was an invalid input. And then we're going to call our function print the first days. So it's going to call the year that our user had input with the start day, and then it's going to print each month. So I think this program is just easier to see it in action. I believe I compiled it. Let's try to run it. Okay, so enter the year. Let's start with where we're at, 2025. And I believe January 1st was on a Wednesday. So that's going to be 3. And so we can see January 1st is Wednesday, February 1st is a Saturday, March 1st is a Saturday, April 1st is a Tuesday, and it goes all the way through the rest of the year. So those are the 4 programs for Assignment 2 in CPSC 5010. Thank you.